This is second part of video lecture of week 10. Here we consider examples on chemical reaction and densities. In an autocatalytic chemical reaction, the reactant and the product are the same. The reaction continues until some saturation level is reached. From experimental evidence, chemists know that the reaction rate is jointly proportional to the amount of the product present and the difference between saturation level and the amount of the product. If the initial concentration of the chemical is 0 and the saturation level is 1, corresponding to 100%, this means that the concentration x of t of chemical satisfies the equation this, where r greater than 0 is constant. This is given to you. Now the question is here, find the concentration of chemical for which the reaction rate x prime t, that is this, is maximum. That is, for what value of x this becomes maximum. So for simplicity, we replace x prime t as fx and then x of t as just x. So x prime t equal to r x of t 1 minus x of t becomes fx is equal to rx 1 minus x. What we are going to do here is, you are asked to find x which is greater than or equal to 0 because chemical reaction has to take place. So it should be equal to and greater than or equal to 0. That maximizes fx. What we do to find the maximum, we need to find the derivative and find the critical numbers. So we find the derivative of this. This r is constant, so it distributes both, and for this we use the product rule. So derivative of x is 1 minus x as it is, then x as it is, and derivative of 1 minus x is minus 1. Simplifies, give you this. Equate to 0 and solve. You will get x is equal to 1 by 2 is the critical number. So for x is equal to 1 by 2, fx is maximum, means x prime t is maximum. To find the what you call limiting value, we need to just put x is equal to 1 by 2 here to get that. An example on density. Note that the rate of change of mass is density. Means if rho is the density, then f is the mass, then rho of x is f prime x. And you see in the example here, the mass of the first x meters of a thin rod is given by this. So this is the mass rate. This is the mass function which is given, where x is measured in meters. The question is here, compute the linear density. You see, mass is given and you are asked to compute the linear density, that is rate of change of mass at x is equal to 2 and at x is equal to 8, and then compare the densities of the 2 points, then conclude. We know rho of x, that is the density, is the rate of change of mass. So rho of x is f prime x. The mass function is given. Use chain rule for this. Square root first, then inside. The answer is this. So this is the density function. This is the mass function for all x. But we need to find the linear density at x is equal to 2, x is equal to 8. Substitute these two here. So we get rho of 2, 1 by 2, rho of 8, 1 by 4. Since the density at x is equal to 2 and x is equal to 8 are different, then we say that the rod is non-homogeneous. That means not homogeneous. In other words, the mass density in the rod is not constant. So non-homogeneous, the density is not constant. Homogeneous, the mass density is constant. In other words, the same example we can say that the rod is less dense at x is equal to 8 because it is 1 by 4, which is less than 1 by 2. So the rod is less dense at x is equal to 8 than x is equal to 2. So here are the examples on this example, same example. And the only difference here is that you are asked to find along with finding x for which the reaction rate is maximum, you need to find the limiting concentration. That is, after you find this x value, substitute here so that you will get the limiting concentration. That's the extra thing here. So the answer is given here. Check it here. So here first find x for which this is maximum, and that value of x you put it here, and that will give you the limiting concentration. Here are the examples on this example 9.6. So only thing you need to conclude whether the rod or whatever here given, whether it is homogeneous or not. The answer for 29 and 31 is given here. Please check the answer. And what we have studied in this week number 10: examples on optimization, examples on related rate, examples on chemical reaction, and some of the examples on density. So with this we conclude the video lecture for week 10. Thank you.